Good afternoon, this is William Brown. Today is October 23rd, 2022. It's currently 5:13 p.m. This is Circ05 for the C attempt. So we're starting here on our code and we're doing our pin definitions. And this allows you to communicate with the shift register, the 74HC595, which I'm going to just refer to the shift register from throughout the video. So we're going to int data equals 2, clock equals 3, and int latch equals 4, which I'm going to show you what that is on the actual Arduino. So here on our digital output, we have 2, 3, and 4. 2 is the blue, 3 is the yellow, and 4 is the green. And that goes over here to our shift register, and it's gonna plug up into, I think, slots J7, J9, and J10. So let's go back to our code. Next, we're going to do our void setup. And what we're doing here is we're just assigning that each pin mode as an output, which is going to be the data, the clock, and the latch. Then we're going to go over here to our void loop. So this is our first void loop. We're going to have int of delay time of 100 milliseconds. And here is going to be our for loop. The initialized expression is going to be I equals 0. Our loop condition is going to be I is less than 256, and our loop expression is going to be I plus plus. And then it's going to update the LED's I to the delay of the delay time. So next, we're doing up here to our to update the LEDs, and basically this sends the LED status in LED statuses to the shift resistor. So it's going to be update LEDs int value of digital write latch low, which pulls the chip latch to low, shift output data clock MSB first value, shifts out 8 bits to the shift register. Digital write latch high pulls the latch high display the data. Next, we're going to update LEDs long. It sends the LED statuses in the LED state to the shift resistor sequence, same as update LEDs, except the shifting out is done in software so you can see what is happening. So update LEDs long int value, digital write latch low, which pulls the chip latch to low, our for loop. It will repeat 8 times, once for each bit, and then the 1 bit equals to the value, and B1, I believe that's 1 million, which uses that bit mask to select only the 8th bit in our number. We are the ones addressing this time through. We move one number up 1 bit value, so next time bit 7 will be bit 8, and we will do our math on it. And then we have an if bit 8 is set, then set our data pin high. If bit 8 is unset, then set the data pin low. Then next 3 lines pulls the clock pin. So that's the code for all of that. And then it pulls the latch high shifting on data in beginning display. And then here, they're used the bitwise math that we use to change individual LEDs. So bits, it starts from 1 and I believe it goes up to 1 million. And then the masks are here displayed. And it changes LED in states. Changes an individual LED. LEDs are 0 to 7 and states is either 0 for off or 1 for on. Changes LED states. LED states equals LED states and mask. And then there's an if statement, which clears the LED states of the bit we are addressing. If the bit is on, we will add it to the LED state and sends the new LED states to the shift register. So all that big old code just does this. As you can see here, we have our 560 ohm resistors. We have 8 LEDs. We have the 5 volt and the ground coming from here over into our breadboard. We have a jumper that jumps that over to the other side. All the LEDs are plugged in on this side minus the first one, which is an orange that's plugged in over there.